right, so for this one, they give us this graph. It is the graph of f. It says the function is continuous, defined from -6 to 5. Now, they don't start this graph at -6, but that's going to come up. So just be aware of that, -6 to 5. So we're missing like part of it here. This shows a portion of the graph, 2 line segments, part of a circle. All right, this is part of a circle. So this, if you want to draw in the whole thing, you can, but this is like a quarter of a circle. Centered at the point 5,3, so this would be the center here. The circle would go around like that. It is known that the point 3, 3 minus square root of 5 is on the graph. That's one of those seemingly totally random pieces of information that's going to come up later. You're like, why on earth are they giving that to us? But you will need it at some point. All right, so kind of ignore that for now. It'll come up later. All right, if integral from -6 to 5, so that's the whole thing, starting at -6 all the way to 5, is 7. Find the value of -6 to -2. So what is that missing part? All right, so integral from -6 to -2 for this function, plus the integral from -2 to 5 of this function. So if we go from -6 to -2, that's the missing bit, plus -2 to 5, that's the part we have. That's going to give us the whole thing from -6 to 5. So it's like part plus part equals the whole thing. It's like you're going on a road trip from -6 to 5, and you just did a rest stop at -2. It's like, well, this part we're missing plus this part we have is going to give us the whole thing. All right, so from -6 to -2, this is what we're looking for. Like that is basically our variable. Like that's the thing we want to try to find. Plus, I'm going to put brackets around this. Now we're going to do the area under the curve from -2 to 5. So we want the area under this graph for us to get this portion of it. Now some of this is going to cancel. We've got this little triangle here. That would be a +1/2. And then this little triangle here, that would be -1/2. So those two cancel. So I'm not really worried about that. And then the same exact thing is going to happen with these two little triangles. This one would be -1/4. And then this one would be +1/4. So those cancel out. Basically, that entire first part up until 1, that all cancels with your above and below sea level portions. So we're starting here. I'm going to do from 1 to 2. This is a trapezoid that's on its side. So trapezoid formula. It's 1/2 times the height, which is 1, and then add the bases together. So this base is 1, this base is 3. So that is that trapezoid. That's giving us this area right here from 1 to 2. And then I need this really weird shaped thing. All right, now what we're going to do is look at this entire square. So that entire square is worth 9. It's a 3 by 3 square. That whole square is going to be 9. And I want to subtract out this quarter of the circle. What we want is this area. We want this part. So I'm going to do this whole square, which is 9, 3 by 3, and I'm going to subtract out the circle. Now we've done semicircles a lot, 1/2 a circle. This one's just a quarter of a circle. So we're going to subtract out that quarter of a circle, which would be 1/4 pi r squared. So it's the exact same thing as a half circle. It's just instead it's a quarter of a circle. Radius is 3. And then this whole thing equals integral from -6 to 5, the whole thing, which they told us is worth 7. All right, so we've got this missing part plus, and then we did this area under the curve for what we've got, and that all equals 7. So if I want this by itself, all I have to do is subtract over all of that. So I'm subtracting over that whole mess. Someone asked where the 9 came from. That's this entire square. It's a 3 by 3 square. So that, or you could just count up and say, oh, there's 9 blocks inside of that. But it's that whole square minus the quarter circle because we want just this area. Yes, good. And we subtracted out this part of the circle. It's a really weird question. They're going to ask you really weird questions. They want you to apply what you've learned in calculus. They're going to ask you something that's like totally different than anything you've ever seen. We can't even anticipate it. They want you to take what you've learned and apply it. So if you're like, hey, we've never done one like this before, yeah, that's what they're going to do to you. It's going to be not like anything you've ever seen. They're going to make it super weird. You have to take what you've learned and apply it to a new situation. And there's no way, I mean, like, I have no idea what the test is going to look like. So these are the best examples I can give you. And so we're going to take this whole thing in the brackets and subtract it over. So it's going to be 7 minus all of that. And you can copy it exactly like it looks, but I'm going to clean a little bit of this up just for the sake of not having to write it all again. 3 plus 1 is 4. Half of that is 2. 2 plus 9 would be 11. And then minus, this would be 9/4 pi. And again, you can copy it exactly like it looks, but just for the sake of not having to write all of that, I just kind of cleaned it up. All right, I'm gonna have to fold the paper over so you guys can see part B. And I'm gonna have to kind of speed things up here for me to finish before 10:20 here. All right, part B, evaluate this integral. Now it's 2f prime of x plus 4. I'm going to separate that into 2 separate integrals so I can deal with the 4 separately. So we're going to make that 2 separate integrals. So antiderivative, well, if this is f prime, the antiderivative would just be f. So this would just be 2f of x. The derivative of f is f prime. We just did that backwards, did an antiderivative. And such that 3 to 5. We're kind of doing this as a part A and a part B problem here. So antiderivative of 4 would be 4x, and then such that 3 to 5. Upper boundary minus lower boundary. So just need to evaluate these. So plugging in 5, 2 times f of 5. Now we got to get that from the graph here. F of 5 is 0. We have the 0.50 there. So if you plug 5 in, f of 5 is 0 minus, and then we have to do 2 times f of 3, which is that really weird thing they gave us. That's why they gave us this. F of 3 is 3 minus square root of 5. If they give you a seemingly random piece of information like that, it's going to come up at some point. You're going to be like, oh, that's where I needed that. All right, so f of 3 was that 3 minus square root of 5. So that's all the first part. Plus, and now the second part, upper boundary minus lower boundary. So if you plug in 5, 4 times 5 is 20, minus 4 times 3 is 12. It's free response, so don't do anything to that. Just leave it alone and move on to the next part. If you try to mess with that and you just add or subtract wrong, it will be wrong. So just leave it alone. All right, part C, function G is given by this accumulation function. The accumulation starts at -2. So just be aware it doesn't start at 0, it's starting at -2. Find the absolute maximum. This is another candidates test. They have us doing another candidates test. So we are going to make our chart for this g of x function. End points are -2 and 5. And then critical points, its derivative equals 0. So our derivative of g, derivative of an integral are going to cancel. And so it would just be f of x. So derivative of g, derivative and integral cancel, that just gives you f of x. We want to set that equal to 0. And so I'm going to look up here at this graph and find where f of x equals 0. So f of x equals 0 at -1. So right there, a half, so right there, and 5, which is already on the chart because it's an end point. So that's both a critical point and an end point. So -1, a half, and 5. All right, and we're going to plug those into function g. Just be aware the accumulation begins at -2, not 0. So if you plug in -2, accumulating from -2 to -2 gives you precisely nothing. You didn't go anywhere. All right, now we're going to plug in -1. So from -2 to -1, that's this little triangle here, which is worth a half. I'm sorry, I have to keep moving this up and down here so you can see it all. All right, and then plugging in a half. So we want to go from -2 to positive a half. So that is from the beginning until right here. So these two triangles are going to cancel out, the positive, the above and the below one. So all we've got is this little guy. It is negative since it's below sea level, and that would be worth a fourth. A triangle is 1/2 base times height. It would be a half times a half, which would be a fourth. So negative a fourth. And then plugging in 5. The integral from -2 to 5, we already did back in part A. From -2 to 5, that was this thing right here, this 11 minus 9/4 pi. It's exactly what we got right there. That was our integral from -2 to 5. So 11 minus 9/4 pi. It's nice when you can reuse part of a previous answer. All right, so it says find the absolute maximum. It's which one of these is the biggest? Well, that's going to be this one here. So the absolute maximum is 11 minus 9/4 pi. And if you want to estimate that, you can, substitute in 3 for pi to get like a general number for that. But with the 11 in there, it's going to be bigger than a half, right? Absolute maximum is 11 minus 9/4 pi at x equals 5. And the chart is your justification. So you don't have to write a because sentence. This is your justification. All right, and then lastly, part D looks really scary. It's actually the easiest part of the whole thing. So again, if part A, B, or C throws you off, don't give up because these don't go easiest to most difficult. It's kind of all jumbled. All right, find limit as x goes to 1 of this thing. All you have to do is plug in 1. Oftentimes they make it come out to 0 over 0, and you have to do L'Hopital's rule because it's an indeterminate. You would get 0 over 0, but this one, that doesn't happen. All you have to do is plug in 1. 10 to the first is 10. All right, minus 3 times f prime of 1. Now we're going to have to evaluate that, so I'm going to come back to that. Over f of 1 minus arctangent of 1. And you don't even have to evaluate arctangent. You can leave that arctangent of 1. Now, arctangent of 1 is pi over 4, but, and I want you to know that. If it was multiple choice, you'd have to know that, but you can leave it like that. The only things you do have to evaluate are these. All right, so f prime of 1. Let's go back up here. Here's 1. Derivative means slope. So we want the slope at 1. So I can throw that question to you guys. Hey guys, what is the slope of this line segment? I want the slope at 1. Good, it is 2. So you just need to know that slope means derivative, right? So this would be 10 minus 3 times 2. You don't have to simplify, just leave it alone. And then f of 1 is just that actual point, which is at 1. F of 1 is 1. It's just that point. And this is the answer. That's all you have to do. So all you have to do is plug in 1. Now, again, usually they make it come out to indeterminate. It would be 0 over 0, and then there'd be more work. But for this one, that's all you had to do. So let me go through and do the points for this one. For part A, you get a point for separating these integrals. So writing out this step. So integral from -6 to 2 plus -2 to 5 gives you the whole thing. So part plus part equals whole thing. You get a point for separating it. You get a point for finding the area under the curve on this graph. So you get a point for this, and then you get a point for subtracting it over to get the final answer. So that last point is just literally for subtracting this over. All right, part B, you get a point for knowing this antiderivative, which is actually pretty easy. Antiderivative of f prime is just f. So you get a point for doing that, and then you get a point for the answer. And then down here, you get a point for saying that g prime is f of x. So you get a point for knowing that derivative. You get a point for evaluating what goes on the table here. So your candidates, and then you get a point for the answer. And then down here, this was only worth 1, but I mean, for heaven's sake, that's all you had to do. So that was only worth 1 point. Again, your goal is to get as many points as possible, but if you're getting around 4 or 5 out of the 9, you are in really good shape.